Hi guys, this is your host Anuj and you are watching Routing and Switching video series. This video series will be in English language. The person who are looking for the same video series in Hindi can visit the another playlist in the same channel. Today the topic is RIP protocol and in this video we will be covering RIP version 1 fundamentals and its characteristics. So let's begin. RIP stands for Routing Information Protocol. RIP is a standardized distance vector routing protocol designed for use in a smaller network. RIP was one of the first true distance vector protocol and it's supported in wide variety of the system. RIP is not a protocol on the way of out. RIP is actually an application which uses UDP port number 520. There are some characteristics of RIP protocol like RIP sends out periodic routing update in every 30 seconds. It means the hello timer of RIP protocol is 30 seconds. RIP sends out the full routing table in every periodic update. RIP uses a form of distance as its metric. It means that the metric is hop count. RIP uses the Bellman-Ford distance vector algorithm to determine best path to particular destination. RIP supports IP and IPX routing. RIP utilizes UDP port number 520 as I told you earlier. RIP routes have an administrative distance of 120, either it's RIP version 1 or RIP version 2. When compared to other interior gateway protocol, RIP is the least preferred routing protocol. Please note that this is irrelevant because you usually do not run multiple routing protocol in the same domain. And even if you did, you can modify the AD values anytime. RIP has a maximum hop count of 15 hops, which means the maximum diameter of the network is 15 hops. A metric of 16 hops in RIP is considered as a poison route or infinity metric. If multiple paths exist to the particular destination, RIP will load balance between those paths. By default is 4 only if the metric is equal. RIP uses a round-robin system of load balancing between equal metric routes, which can lead to the pinhole congestion. Why I'm saying these things? Let me tell you with the example. Two paths might exist to the particular destination, one going through a 10 gig link and the another going to the 100 gig link. If metric is equal, RIP will load balance sending an equal amount of traffic down to the 10 Mbps link and the 100 Mbps links. This will cause the slower link to become congested. Hope you understood well. If we talk about the RIP version, RIP has two versions, version 1 and version 2. Mr. Hendrick wrote RFC 1058 in 1988 in which he documented the existing protocol and specified some improvements. RIP version 1 is a classful routing protocol, which means it does not include the subnet mask with its routing table updates. Because of this, RIP version 1 does not support VLSM or subnetting. When using RIP version 1, network must be contiguous and subnets of the major network must be configured with identical subnet mask. There are some more parameters. RIP version 1 sends update as broadcast to the address 255, 255, 255, 255, which means when a router is sending update to the peer router, in source field it has its own exit interface IP address and in the destination field it uses 255, 255, 255, 255. RIP version 1 router will only send RIP version 1 packet, whereas RIP version 1 router is capable to receive both version 1 and version 2 updates. If we talk about the RIP timers, RIP have 4 basic timers. First one is update timer, which is called hello timer. Second one is invalid timer. Third one is hold down timer and the fourth one is plus timer. Let's check the detailed information about these timers. Update timer or the hello timer. In RIP, the default periodic time is 30 seconds. That indicates how often the router will send out a routing table update to the peer router. It means that a RIP router will always send a routing update to the peer router in every 30 seconds. Second one is invalid timer. and the default value for the invalid timer is 180. That indicates how long a route will remain in routing table before being marked as invalid. The invalid timer will be reset if an update is received for the particular route before the timer expires. Always remember, a route marked as invalid is not immediately removed from the routing table. Instead, the route is marked with a metric of 16 indicating it is unreachable and placed in a hold down state. The third timer is hold down timer. As I told you, the default value for the hold down timer is 180 seconds. It indicates how long RIP will suppress a route that it has placed in hold down state. RIP will not accept any new updates for the routes in a hold down state until the hold down timer is expires. A route can be entered into a hold down state for one of three reasons. The first one is the invalid timer has been expired. The second one is an update has been received from another router, marking that route with a metric of 16. Third one is an update has been received from another router, marking that the route with a higher metric than what is currently in the routing table. This is to prevent the loop. Fourth one is flush timer. The default value for the flush timer is 240 seconds. It indicates how long a route can remain in a routing table before being flushed. If no updates are heard about this route, the flush timer runs concurrently with the invalid timer and it will flush the route right after 16 seconds. Please remember, RIP timer must be identical on all the routers on the RIP network, otherwise massive instability will occur. If we talk about the RIP loop avoidance mechanism, RIP has three major loop avoidance mechanisms. By the time in this video, I'm not going to cover the detailed information of the loop avoidance mechanism. However, I will tell what are those. The very first one is split horizon rule. The second one is route poisoning. The third one is hold down timer. You may be aware RIP version 1 do not include the subnet mask information in the routing table updates. However, the routing table include RIP version 1 routes with both the network address and the subnet mask. So how does a router running with RIP version 1 determines what subnet mask it should apply to the route when adding to the routing table? There are two rules used by RIP version 1 to determine what subnet mask it should apply to the route when adding to the routing table. First one, if a routing update and the interface on which it is received belong to the same major network, the subnet mask of the interface is applied to the network in the routing table. Second one, if a routing update and the interface on which it is received belong to the different major network, the classful subnet mask of the network is applied to the network in the routing table. So this is a basic information about the RIP protocol. Let me summarize all the points in short to understand more. RIP stands for Routing Information Protocol. RIP is a distance vector routing protocol. It is an application protocol which uses UDP port number 520. RIP has administrative distance value of 120. RIP uses broadcast address 255, 255, 255, 255 in destination field while sending an update to the peer router. RIP has maximum hop count is 15. And if it is 16, it will be considered as unreachable. For RIP, hello timer is 30 seconds, invalid timer is 180 seconds, hold down timer is 180 seconds, and flush timer is 240 seconds. RIP load balance the traffic in round robin manner if the metric is equal. Loop avoidance mechanism like split horizon rule, route poisoning, and hold down timer helps RIP to function properly in the network. I hope this video helped you to understand the basic information about the RIP protocol. If so, please like the video, subscribe the channel and hit the bell icon so that you won't miss the notification of the upcoming videos. It's time to say bye. See you in the next video and we'll cover much more. Take care of yourself and your loved ones.